What's up, guys? This is Trust Anchor Labs, and this series is going to be detailing an enterprise PKI lab. Quick note before we start, this is a lab environment designed to teach the mechanics of the PKI setup. For the sake of the video, I'm keeping things simple and skipping some of the production hardening steps. If you're deploying this in a real environment, you'll need additional security controls. This is your foundation to build on. It's not a production blueprint. Just keep that in mind. First and foremost, what is PKI? PKI, or public key infrastructure, is one of those technologies that almost everybody utilizes in some way, but very few people actually understand or deploy it correctly. When most people think about certificates, they think about HTTPS websites, but PKI goes way beyond that. In enterprise environments, PKI enables smart card authentication, phishing resistant MFA, network authentication, device certificates, code signing, and trust itself. In this series, we're going to build an actual enterprise-style PKI environment from scratch. Not just a quick CA demo, but we're going to be going over things like building a real enterprise-style PKI environment. We're going to deploy a two-tier certificate authority hierarchy. We're going to go over configuring CRLs and AIA distribution using Microsoft's Internet Information Service. We're going to create certificate templates. We're going to deploy smart card authentication with YubiKeys for Windows login. We're also going to integrate hybrid identity with Entra ID. In this first episode, we're going to build out the foundations of the PKI infrastructure, including the root or offline certification authority, the issuing certification authority, and the trust chain that everything else in the series will rely on. Now, single tier versus multi-tier PKI is pretty important. Some of the differences: in a single tier, you have one CA that's going to handle trust and issuances. The problem with this is that compromise of a single CA compromises everything. You lose the trust, you lose issuance. However, in a multi-tier, you're going to have a root CA that remains offline. That's going to be basically your trust establishment. And you may have multiple subordinate CAs that handle different things. The root CA establishes the trust. All of these subordinate issues are trusted by the root to issue certificates. In this lab, it's a relatively simple infrastructure. We have a domain controller, a Windows client, and we have two CAs. We have the one offline CA, and we have the subordinate CA that is trusted by the root. On the subordinate CA, we're also going to host the CRLs using IIS. You may see this being hosted externally. It may be on its own individual server, and it may actually be hosted publicly for external access. We're going to start by installing and configuring the root certification authority. And a little bit about the design. As I mentioned, it's going to be a standalone CA. This one is not going to be domain joined, and it's going to remain offline unless it's needed. Why it may be needed: if a subordinate CA certification expires, you may need to re-enroll it, and that would require the root CA to issue a new certificate. It's also going to be set up with a longer certificate validity, since it is going to be offline and not used very often. And it's essentially going to be the foundation. Now we can get into the actual installation and configuration. As you can see, I already have all of our infrastructure set up. We have our domain controller, our root certification authority, our subordinate CA, as well as our Windows client. I'm not going to go too in depth on the actual setup of the infrastructure. If you would like me to make a video entailing the actual setup of the infrastructure, including the domain setup, leave a comment and I can make that an additional video. Get started on the root CA. Once you install the server, get everything set up, get it attached to the network, you can open the server manager. You're going to click manage and add roles. And for the root CA, it's pretty simple. I'm going to click next a few times. Once you get to the server selection, just make sure that the host name and the IP address is correct. You're going to click next, and you're going to select the Active Directory Certificate Services. Next, everything is pretty much default on this. On the root CA, all you need is a certification authority. You don't need any of the websites. Next, restart the server if needed. Then click install. This can take a minute, so I'm going to pause until this is finished up. Once that finishes installation, there is some additional configuration that needs to be done. You can tell by the alert next to the flag. You'll see configure Active Directory certificates. We'll go ahead and click on that. Click next. We'll use basic administrator credentials to set this up. We'll do the certification authority since that's all added. And since this is not a domain join machine, the only option you will have is standalone. If it was joined to the domain, you would be able to select an enterprise CA. We'll go ahead and select that. We're going to select our root CA as this is going to be our trust foundation. Next, we're going to create a new private key since we don't currently have one. We're going to select RSA with a 4096. You can do a 2048. I just like using 4096 with a SHA-256 hashing out. For the common name, we can leave this the same. Next, validity we're going to have set for 5 years. This doesn't necessarily need to change unless certain compliance regulations require it. As I mentioned before, since this CA is mainly offline and not domain joined, it's okay to have a longer validity period. Just click configure. It'll be done pretty quickly. Once that is installed, you should be able to open up certification authority. And if you have this check mark, that means that it is running and it is working. So a little bit of a configuration changes that we need to make. I'm going to right click on the server, go to properties, and this is going to be the main thing, the CRL and the AIA. And what this is it's essentially your certification revocation list. So anytime that a certificate is revoked, this list is going to reference those certificates. That way, if a certification gets revoked, it is no longer valid and it cannot be used for any purpose. Properties. A couple things that we're going to change. So first and foremost, you have the local storage of the CRL, which is going to be saved at Windows System 32/start server. And that's going to be the local location. You also want it to be published somewhere that is accessible by all endpoints. And the reason for that is if a client cannot reach the CRL, it will not be able to verify a certificate's validity. What we are going to do, we're going to create a custom location for it. We're going to click add. We're going to copy the example, and the way that I'm going to have it set up, I'll explain this a little bit more in depth in a few minutes. We're going to set it for PKI trustanchorlabs.com/PKI. And that'll be /CA name, CRL name suffix, and delta CRL allowed. The delta CRL allowed is extremely important. If you leave this out, certificates will not be able to access the correct CRL. Go ahead and click OK. Now for the HTTP location, you want to make sure that you check include in CRLs and include in CDP. That way this is actually added to the certificates that are issued. And with that added, we can delete the default HTTP address. And then we'll do the same thing with the AIA. Click add. Copy the example. And the difference here is you'll have the certificate name .cfp instead of the delta CRL. Change this to PKI trustanchorlabs.com. PKI. Click OK. Old one. Make sure we include the AIA extension. Apply. That will restart the services. Now, obviously, you're going to want these relatively hardened. We're not going to go too in depth in the hardening of the PKI environment in this series. I may touch on a few things, but this in general is pretty fine. So, one thing that we need to do, talk about why offline actually matters. The reason that we keep the root CA offline. For one, it reduces the attack surface, it protects the trust anchor. The root CA rarely changes, so it doesn't necessarily need to be online, and it limits the impact of compromise. As I mentioned before, some environments may have a root certification authority as well as multiple subordinate authorities for different functions reasons. If one of those subordinates were to get compromised, you could completely start from scratch, rebuild that subordinate, give it a new certificate from root, and you're good to go. If you're in a standalone environment where your root CA is your issuing CA, if it gets compromised, lose the trust foundation, lose your issuing certifications foundation. So that's why we leave the root CA offline and have subordinate CAs to do the actual issuing. So at this point, the root CA is online and it's operational, but it's not going to be actually issuing certificates directly to users or system. Its primary responsibility is just going to be signing certificates for the subordinate CAs so that they can issue certificates. One thing that I do need to point out before we get into creating the subordinate CAs, as I mentioned, we have this pki.trustanchorlabs.com/PKI as our CRL distribution point. What we need to do for that is we need to make sure that this is accessible. And the way that we're going to do it, our subordinate CA is going to be hosting IIS, but our subordinate CA is obviously not called PKI. So the fully qualified domain name pki.trustanchorlabs.com is not going to resolve to anything. So on our DC, what I'm actually going to do is I'm going to add a DNS for it. And what that'll be is it'll just be a CNAME record. I'm going to do the alias of PKI and the fully qualified domain name of KL, that's subCA. Trustanchorlabs.com. And what that will allow us to do, if I flush the DNS, do a NS lookup on PKI, trustanchorlabs.com, it should resolve to the PAL subCA. And I'll get into setting up that IIS here momentarily. We have the alias, we have the CRL setup in root CA. We go to the local storage, go to Winder, system 32, server. If we need to publish new CRLs under the certification authority, you can right click on revoked certificates, go to all tasks and publish, and that should post new CRL. All right, now that the root CA is set up and essentially ready to go, we're going to move on to the issuing subordinate CA. A little bit about how it's designed. It's going to be domain joined, and it's going to be an enterprise CA. So it's going to be integrated with Active Directory. It's going to be responsible for issuing client or user certificates. It's going to host all of our certificate templates that we make. It's going to support auto enrollment. We're also going to be setting up IIS on this device to publish CRLs. As I mentioned before, sometimes you'll see CRLs hosted on their own independent IIS server. You may also see them posted publicly. That way they're accessible external to into the actual installation of it. It's very straightforward. It's very similar to the root CA. I'm going to click Manage under the Server Manager, add roles and features. I'm going to click Next, ensure that the host name and the IP address are correct. Next, I'm going to select Active Directory Certificate Services. Add features, click Next. Now, with this one, we're also going to add the Certification Authority web enrollment. And that'll install IIS, essentially set up most settings. Click Next a few times. Good. Restart the server. Needed. And then click Install. I'll pause until this finishes. Now, once this is finished, Similar to the root CA, we do have to configure it. However, before I do that, what we need to do is we need to configure IIS. And the reason for that is on our root CA, we set the HTTP location. So what we're going to do in IIS, already done for me, but I'm just going to redo it. Go to default website. You're going to add a virtual directory. Alias is going to be PKI for that /PKI in the CRO, and the physical path is going to be Windows, inetpub, www.root, PKI. And you may need to create this. Now, the reason for that, back on our root CA, we remember the CRL and certification authority. Go to our properties. That CRL distribution that we configured is at PKI trustanchorlabs.com/PKI. We added the CNAME record in our DNS to point to this server when accessing pki.trustanchorlabs.com, and this PKI is going to be our virtual directory. We go to that location, that inetpub www.root PKI, left over earlier, but we are going to need those certificates installed here. We go back to the root CA. We can go to our local storage, which by default is at Windows System 32 cert servers, cert and roll. We're going to copy this URL and navigate to our subordinate CA. Go to that inetpub www.root PKI directory. We're going to paste that here. So now that that's installed, just as a test, let me flush my DNS here. Config flush DNS. If we go to our browser, go to http pki.trust.com/pki/ theoretically, this should download the file. Not found. Do a little bit of troubleshooting. See if our IIS is actually. Does it appear to be? Got the labs. trustanchorlabs.com. Okay, so that does download that file. Our IIS is good. Like I mentioned before, I'm not going to get too deep into actually hardening of the services. Something simple that you can do is you can disable directory browsing, which should be done by default. And essentially what that does is it prevents you from being able to browse other directories. So if we go to pki.trustanchor.com/pki, without an actual file, it should be forbidden. Which helps prevent directory traverse. So with that set up, what we can do is we can go ahead and configure Active Directory certificate services. It'll be very similar to how we set up the root CA. However, We're also going to select this certification authority web enrollment. Next, since this device is domain joined, we can choose enterprise CA instead of standalone. Next, this is going to be a subordinate CA. Now, once you do this, you'll create a private key. We're going to keep it the same as we created with the root CA, RSA with a 4096 key length and a SHA-256 algorithm. I'm going to change this common name just to make it a little bit simpler. That way it's TAL sub CA1. Next, and since this is a subordinate CA, it's going to require a certificate request to be made. Sometimes you can send the certificate to a parent computer, but with it not being on the domain, we're just going to save the certificate request to a file. That, we can click next, we can configure. Configuration succeeded. The warning that we're getting, since it is a subordinate CA, we have to get that request approved and install a certificate to the CA for it to function correctly. We go to our C drive, we should have that request file. And what we'll do with this, we will go to the root CA. We're going to transfer that file over to the root. You can just copy it over to the C drive. And then on the certification authority, we can go to all tasks, submit new request. And we can go to this newly created request file, open it up. Now under pending request, you should now see this taken under submission request. You can see the requester's name is the administrator, and the request common name is going to be our sub CA. So if we right click on that, go to all tasks, issue, you should now see that in the issued service, as well as all the information. So you have the sub CA as issued to, it's issued by the root CA, and we should see under URL distribution points, you should see that PKI Trust Anchor Labs URL. And under the certification path, you should see TAL root CA followed by the sub CA. This is going to be your trust chain. So we'll go to details, copy the file. Next, and essentially we're exporting that certificate so that we can install it on the sub CA. Ensure that you select cryptographic message syntax, which is going to be your P7B file, and include all certificates in the. We're going to just save it on our C drive. Subca.p7b. Old one. Make sure that you're including all certificates in the certification path, and export keys should be known. So once we get that exported, we can copy it. We can move it back to the subordinates. Paste it there. Now if we go back to the sub CA, we should see it in our C drive. Once we have it moved over, we can open the certification authority. Under our server, we can right click, all tasks, and install CA certificate. Select this sub CA P7B certificate. And this is saying that the root certificate is untrusted. You wish to trust the root certificate on this machine. And what that'll do is that'll install that root certificate and allow it to be trusted on subordinates. Click OK. You're going to right click the server again, go to all tasks, start the service. And if it worked correctly, you should see a new check mark there, which means that this is now trusted by the root. We go to properties of that server. We have a CA certificate number 0. If we view that, you should see issue to sub CA, issued by root, and the certification path should show both certificates. Now that our trust hierarchy is established, we can go ahead and adjust the properties of our subordinate CA. And this is going to be very similar to the root CA as well. You're going to go to extensions, Since we do have the IIS server running, we can go ahead and change this to the correct location. So instead of Windows System 32, we can go ahead and save that to our inet pub location. Here, root, copy path, copy that there. We're going to name CRL name suffix, delta CRL cloud. Added, we can publish CRLs to that location. We can remove the old version. Then we need to add the CRL extension. Copy this default. Here, I'm going to change this PKI dot trust anchor labs.com/PKI. Default HTTP location, and then include in CRL. That'll restart the service. Properties, verify took. Yep. Now if we right click revoke certificates, all tests, and publish, new CRL, you should now see that here. We have our CRL and our delta CRL. Delta CRL is indicated by the plus sign. Now that we have the trust hierarchy finished, what we need to think about is trust distribution. What I mean by that, in order for a certificate to be valid and work, the computer using the certificate has to trust the issuer. And with our multi-tier environment, that involves trusting the issuing certification authority as well as the root certification authority. In order to do that, we're going to implement GPOs. So looking at this Windows client machine, if we look at the trusted root certificates, obviously our root certificate is not going to be, or our root CA is not. Same with intermediate certification. Our subordinate CA is not. Obviously, we could manually do this on each computer, but obviously, if you have thousands of endpoints, that's not really feasible. We're going to implement GPO to do. To start this process, what I'm actually going to do, obviously, I'm going to keep my OU structure relatively simple for the purposes of this series. So what I'm going to do is I'm just going to create a security group, and we'll call this PKI Trusted Computers. And what I'll do is I will just add this to currently my only computer. I go to member of. Well, I'll go to my computer properties, go to member of, and we will add that PKI Trusted Computer group. Apply that. Now for the GPO. I just created this GPO. I called it PKI Trusted CAs to make sure that it's not going to attach to every single computer and just targets that group. We'll go to delegation, go to advanced. You're going to want to turn apply group policy off of authenticated users. The reason for that is if that is turned on, every computer, no matter what group it's in, will have this group policy applied. I'm going to add a group to it. I'm going to do the PKI Trusted Computers. And we're going to apply group policy for apply there. Now, if you go to scope, you should see PKI Trusted Computers in your security filter. Now, to set the trusted CAs, you're going to edit the group policy object. Under computer configuration, you'll go to policies, Windows settings, security settings, and then public key policies. In this section, you have trusted root certification authorities and intermediate certification authorities. So what we have to actually do, we have to upload the certificates to that GPU. So if I go to our root certification authority, we'll go to properties, view certificate, go to details, copy the file, and we will download it as a .c or a x.509 certificate. Do root, save it to our C drive, copy it, and we can move it over to our domain. And obviously you may have some NTFS permissions in place that prevent that, but just for the purposes of this video, to make it a little bit easier, we're just going to do it. And then you'll do the same with the sub. I believe we already have this one saved. We'll save it as a 509 file, save it to C drive sub, and we will do the same. Copy that file, paste it onto our main controller or whatever device you're using for the group policy management. So now under our public key policies in our GPO, we go to trusted root certification authorities. We can right click the window, click import, next, C drive, and import that root cert. Next, finish, import was successful, so we see that there. Do intermediate certification authorities and do the same thing here with subordinate certificate. Next, make sure that you place all certificates in the certification authority store. Finish. Successful. And that is it for the GPO. Now, if you go to this GPO now, go to settings, you should see security settings, public key. You should see the root added. You should also see the last thing you need to do is link that policy. For the sake of this series, I'm just going to link it domain-wide. You may prefer linking it to each individual workstation OU depending on your infrastructure. But for the sake of this video, I'm just going to link it to our domain. Since we do already have it filtered to that specific security group, the PKI Trusted Computers, it should only apply to that. Now that that GPO is added, we can go to our admin workstation. Run a GP update. And just to verify, let me run the GP result. We should see PKI trusted CAs, but it's currently being denied. So just verify. We are in the trusted computers group. So we may need to restart this. And of course it's on. I'll pause until the update. All right, now that updates are finished and the workstation is restarted, we can check to see if that group policy update applied. The results are roll up. We should see computer settings, applied group policy objects, and the AI trusted. Now, in order to verify that, we can go to Cert MGR, Manage Computer Certificates. Now, if we go to Trusted Root Certification Certificates, we should now see TAL-root. Same with intermediate certifications, we should see the sub CA1. We should also see that it's issued by root, as well as the expiration. Now, why is that important? It's important because if you don't have the CAs installed on endpoints, once you begin issuing enrollment agent certificates or smart card login certificates, if they don't trust the issuing CA, the authentication on those won't work, and you'll get an error saying that the trust chain couldn't be validated or issuing CA is not trusted. So clients must trust the root CA, and they also have to trust the issuing CA because it's signed by root. Root policy is the best way to do it because, like I mentioned, if you have hundreds to thousands of endpoints, you won't be able to install those manually. What's next? Now that we have trust validated and we have distributed trust on endpoints, we can start creating the templates. And this will include the enrollment agent certificate, which will allow administrators to enroll users in smart card login certificates or enroll device certificates. We'll also begin provisioning the YubiKeys for smart card login, and from there we'll deploy phishing resistant MFA via Intra ID. That's about it for this video. At this point, our trust hierarchy is operational, our clients trust the environment, and the foundation for enterprise authentication is. Be sure to keep an eye out for the next video where we'll start actually implementing some of the certificates and authentication methods. If you have any questions or input, please leave a comment below. And if you learned anything or if this video helped at all, feel free to give a like and subscribe. I'll see you next time.